Of homework 3C, we're going to look at term structures. Okay. Time to maturity affects interest rates because time increases. The longer the security is into the future, it increases our exposure to risk. So this first blank is increases, causing investors to demand higher yields on securities with longer maturities. The term structure of interest rates refers to the difference in the yields on securities that are identical except for their term to maturity. Okay? So they're identical. So if you're talking about the term structure of, say, treasury bonds, you want to look at all treasury bonds that have, coupon payments, face value, that have different maturities. So everything about the treasury bonds are identical except for their maturities: 1 year, 2 year, 3 year, 4 year, 5 year, 6 year, 10 year, 20 year, 30 year. Okay, so the only difference is their maturity. Okay. So here are some term structure facts from our textbook. Interest rates on bonds of different maturities move together over time. That's fact one. When short-term interest rates are low, yield curves are more likely to have an upward slope. When short-term rates are high, yield curves are more likely to have slope downward and be inverted. And then fact number three, yield curves almost always slope upward. Okay, the figure below supports term structure facts what? Well, if you look at a given year, right? If you look at a given year, this is a 3-month, this is the 3 to 5 year, and this is the 20 year. Well, you're climbing up the ladder, so the yield curve is upward sloping, upward sloping, upward sloping, upward sloping, upward sloping. So fact number three seems to hold. They generally, almost always, slope upward. And they're generally moving through time, right? We have downward movements, upward movements, downward movements, upward movements, downward movements. So they also generally move together through time. So one holds as well, right? Okay, so when short-term rates are low, when is a short-term rate low? Right here. Short-term rate is low. The yield curve is pretty steep. When short-term rates are high, the yield curve is pretty flat. And you can see that here. So it looks like 1 through 3 are supported by this diagram. Okay. Down here, we have this yield curve. We have 3 of them. We have the yield curve from a year ago. We have the yield curve, the light brown or light grayish, brownish. That's the yield curve from a month ago. And then we have Thursday's yield curve, which is blue. Okay, so this graph supports term structure facts. Does it support fact one? Well, you really can't see fact one, can you? Here you definitely see their trends through time, right? You don't really see that down here. When short-term rates are low, yield curves are more likely to have an upward slope. So the short-term rate here is really low. It's the lowest of the 3, right? And it's the steepest. So definitely 2. And what about 3? Well, all 3 of these slope upward, so I would say 2 and 3. Okay. Now in this figure, figure A is predicting what? It's predicting the economy will expand. The steeper the yield curve, the more likely the economy is expanding rapidly. What about figure D? Figure D is suggesting the economy is going to contract. We're going to go into a recession. Yield curves that are historically inverted, where the short-term rate is higher than the long-term rate, predicts a recession, or that the economy will contract. GDP next year will be smaller than it is this year. Okay, so we got all those correct. All right. So now we're going to look at two theories. We have expectations theory, which is in this column. And then we have liquidity preference theory, which is in this column. And it just enhances expectations theory with what's called the liquidity premium. Okay, I'm going to go ahead and copy this into Excel to make it easier to work with. Let me expand Excel out to here, and we don't need, I'll just paste it right here. Okay, and then I'll format it up a little bit, and we'll get rid of this stuff here. Let me change this to numbers because it's already in percentages. There we go. So this is in percentages, right? Just cleaning it up. Okay, we could put a bracket around that, or a border around that, and then put borders around this. Okay, it looks nice and clean now. Okay, so we have to come up with the expectations theory valuation of a yield on a 6-year bond. Now, this is the yield on a 1-year bond, on a bond that matures in 1 year. So if this is 2019, this bond was issued at the beginning of 2019 and will be redeemed in 2020. So we can think, I'll just do this real quick. Let me blow this up a little bit so we can see it. I'll widen it out, actually. So you can think of this as the 1-year bond that was issued in 2019 that's going to be redeemed in 2020. Whoops. This is a bond that will be issued next year and will be redeemed in 2021. This is a bond that will be issued in 2021 and be redeemed in 2022. So this is a bond that will be issued or auctioned in 2022 that will be redeemed in 2023. The bond that is auctioned in 2023 and redeemed in 2024 has an expected yield of 7%. A bond that will be issued in 2024 and redeemed in 2025 has an expected yield of 7.27%. So this is the actual yield on a 1-year bond today. This is what we expect that 1-year bond to be in a year, in 2 years, in 3 years, in 4 years, and in 5 years. Okay? So these are expected values for 1-year treasuries today, in a year, in 2 years, in 3 years, in 4 years, and in 5 years. Okay? So the way expectations theory works is that, so if today, in 2019, suppose in 2019, we want to buy a 6-year bond. Well, we have two choices. We'll keep it simple. We have two choices. We can buy this series of these 6 1-year bonds, right? So when we redeem this next year, we'll buy this in 2020. We'll sell it in 2021. We'll buy this in 2021 and redeem it in 2022. We'll buy this bond in 2022, redeem it in 2023. Then we'll buy this 1-year bond in 2023 and redeem it in 2024. And then we'll buy this bond in 2024 and redeem it in 2025. So we can buy we can buy 6 consecutive 1-year bonds, or we could just buy a 6-year bond. And so expectations theory says that the 6-year bond we buy in 2019 will equal the average of these 6 bonds. Okay, so what this is saying is, in expectations theory, expectations is just an average. If we want to buy a 6-year bond, we can buy a 6-year bond that will have this interest rate, and it's the average of these 1-year bonds that we could buy consecutively. Okay, so when we're calculating this interest rate, it's really the year is actually 2019, but the maturity is 6 year. So what we'll do is we'll put in a new column here. The term to maturity is 6. So this really is term to maturity when we're talking about multiple year bonds. Okay, and these years are all 2019. So 1, 2, 3, 4, 5, 6. Okay. Okay, so this is the 1-year bond we buy in 2019. This is the 1-year bond we buy in 2020. This is the 1-year bond we buy in 2021. This is 1-year bond we expect to buy in 2002, 2023, and 2024. Okay, so at time 2019, if we buy a 6-year bond, and these are expected values of these future yields on 1-year treasuries, according to expectations theory, the yield on this 6-year bond will be the average of these 6 1-year expected yields. Okay, now here's a cool way to calculate this. I'm going to freeze the first year by pushing F4. It puts dollar signs in front of the C and the 6. If I pull this back 1 year and check the equation there. Whoops, let me put the other. I check the equation. Look what happens. The dollar signs on C freeze that first row, but since I didn't do that to the last one, it varies. So I can get these averages very quickly. Okay, and then I can type in that number there. Okay, so the average of 1 is just that, right? The average of 2 is the first 2. The 3-year bond will average these 3 1-year yields. The 4-year bond will average these 4-year 1-year bonds. The 5-year bond will average these 5 annual 1-year bonds. And the 6-year bond will average all 6 of these 1-year bonds. And that's expectations theory. So what I'm going to do is I'm going to slide this over like this, so I can type them into my table over here. So this is 4.69. This is 5.27, 5.62, 5.89. And notice what's happening. The yields are all rising, right? Because the longer the maturity of the bond, the more exposure you have, more risk you're exposed to. Okay. Now, what about the liquidity premium? I'll slide this over like this. Okay. So down here, let's just answer this first question. In 1 year from now, you expect the yield on a 1 year bond to be 5.85, right? Because we're talking about a 1 year bond. 1 year bond. And these are a list of 1 year bonds. So 1 year from now, you expect the yield on a 1 year bond to be 5.85. In 4 years from now, you expect the yield to be 7. 1, 2, 3, 4. Okay, so use expectations here to compute the yields on, we did that. And then insert these values in the third column on the above table, which we did. Okay, the maturity premium on a 2-year bond equals what? Here's a 2-year bond. What's the maturity premium? Well, the maturity premium is the difference between these two. So let me just go over here. So the maturity premium on the 2-year bond is that value minus, whoops, I'm in the wrong column. I'm supposed to be in this column. Because this is the yield on 2-year bond in 2019 minus the 1-year bond yield, and that is 0.58. So 0.58. Okay. The maturity premium on a 4-year bond equals what? So now we're looking at a 4-year bond, right? So 1-year bond, 2-year bond, 3-year bond, 4-year bond. So equals 1, 2, 3, 4 minus the 1 year, 1.20. Those are the maturity premiums. And the maturity premium on a 6-year bond is 1-year bond, 2-year bond, 3-year bond, 4-year bond, 5-year bond, 6-year bond minus the 1-year bond, 1.61. So as the maturity increases, the premium that we require goes up. We need a higher yield. Okay. Okay, now this is just a hypothetical liquidity premium that I just made up. It's just a function I made up. It's a function of how the maturity of the bond, right? Okay, so I'm gonna calculate the liquidity premium. So the liquidity premium is 0.77 times maturity, which was over here, minus 1. So the liquidity premium of a 1-year bond is 0, right? But the liquidity premium of a 2-year bond is not, right? You got this 1-year bond. There's no liquidity premium on it because you're going to liquidate it at the end of the period. For the 2-year bond, you got to wait an extra year, so you need a little premium there, right? So these are the liquidity premiums, and in reality, it's not going to be linear, but I'm just trying to keep it simple. Whoop. The maturity minus 1. And we get 2.85. Okay, so liquidity preference theory is such that you add to the expectations theory yield, you add to it liquidity premium, right? You add the two together. Oops. So you're just adding these two together. See it? You just add them together. So it enhances liquidity preference theory. Okay. So I'll go ahead and punch these in now to our, whoop. I'll go ahead and punch these into our table here. So we got 0, 4.69, 0.77, 6.04, 1.54, 7.16, 2.31, 8.20, 3.08, 9.19, 3.85, and 10.15. Hit enter, we should get all that right. And we do. Okay, cool. Okay, so in this, okay, now what you want to do is in the same graph, plot the expectations yield curve with the liquidity premium yield curve. So let's do that here. I'm gonna highlight this is gonna be my x-axis, and this is gonna be my y-axis. So I'm holding on the control button to do this, okay? And then I'm gonna go to Insert, Scatter Plot, okay? And then I can right-click and format the data series. Solid line, yeah, solid line. Okay, good. And then I can smooth the line, right? I can right-click on this to show the, to magnify the curve here. I can change the value of the origin from 0 to 4. So you can see the curve. There you go. Okay, and this right here is expectations theory. Okay. Now the cool thing about Excel is I can copy this diagram and I can put it over here. So I have the expectations theory over here. I'm going to go ahead and put liquidity preference theory here. I'll just call it LP, liquidity preference theory. Okay. And I'll pull this down here. So I'm going to click on this line here, and then I'm going to pull this over to liquidity preference theory. Now all of a sudden I have my liquidity preference theory yield curve, and I have my expectations theory yield curve. If I copy this and then delete it and paste it around here, that's kind of cool, right? So this is we'll call this the yield curve, right? And then we'll insert a legend. Design, we'll add a legend. Okay. And I think all we have to do is click on that, and then down here we can click on right before that first comma, between the parenthesis and that first comma, we can click on I'll just click on here and then I'll change it. We'll call this expectations. Okay. And we'll call this liquidity premium. Okay, so you have, and then we can move this legend over here and then widen this up. So this is the yield curve. These are the yield curves based on liquidity premium theory and expectations theory. Okay, so as the maturity increases, the yields go up because we're increasing our risk to exposure, right? Inflation can be a real problem in the future, and if that is the case, the future coupon payments of our securities will be eroded by that inflation. Okay, so that, you would need to do this on your memo. Turn that in. Okay, the vertical distance between the two yield curves is the liquidity premium. So if I put my cursor there, you can see the, I don't know if you can see that, it's 10.15. The height is 10.15, which is that value. And the height of this curve is 6.30, that value. So if I take the difference of these two, I get the 3.85, the liquidity premium. Okay, so let me go back to, where is it at? So this is the liquidity premium. That last answer is liquidity premium. And it looks like we got everything correct. So that concludes question 4 from homework 3C.